Now, all right, if I'm going from the left side to the right side, it's expanding. If I'm going from the right side to the left side, it's right as a simplified log. If you go, okay, I'm about to teach you the properties, log properties. And what I'm telling you is you have to be able to go backwards and forwards. You need to know which way to go. If I ask you to expand a log, I'm saying take the left-hand side, use the rule to go from left to right. The left form to the right form.
So what are you doing going left to right? Like solving?
Okay, here's the way this works. The reason we need to know these log properties is because we have to solve log equations. And in order to solve log equations, what you end up with is you have a simplified, you have to expand it, do some operation on it, and then simplify it back. Okay? So it's like in algebra where you would have to probably multiply a binomial, combine like terms, and then factor it again. Same idea. We have to break it apart to something we can manage, do some operation to it, and then mush it back together at the end. Right? Okay. So the way these all work is you take what's on the left-hand side, and there's a relationship on the right. Now, one of the things we need to write down is we need to write down natural log properties, because natural log is a log. So over here to the side, I'm going to write it right here. Right here. So we're going to just write that log base E of x is equal to natural log of x. Because natural log is the log for base E. When you were in Algebra 2, they remember the base E to the x that we did? Right? That's how you undo E to the x is with natural log. And the way you undo natural log is with E to the x. They are inverses. It's like a square root in a square. So over here, we're also going to write down here that if I do natural log of E to the x, it equals x, because natural log and E are inverses. If I do E to the natural log of x, it also equals x, because they undo each other. Okay. The exponential function and natural log functions are inverses. That means they undo each other. It's like squaring a square root or square rooting a square. Okay? So if I take if the outer function is natural log and the inner function is e to the x, then the answer is x, because natural log and e undo each other. If it's e and it's raised to the natural log of x, the e and natural log undo each other and you get x. We'll get to the other bases. There are other bases. They do the same thing. We'll get to that.
The base isn't always e?
No. Do you remember when you did in Algebra 2 when it was log and it didn't have a base written at all? That was base 10. And then if it says log little 2 lower and then x, that means log base 2 of x. That means to undo that, you would have 2 to a power.
What does the base do?
We just did bases. When we did 2x, it was 2, and it was 0. It was the negative 1 was a half, remember? And 0 was 1, and 1 was 2, and 2 was 4. That's bases. This undoes it. These are inverses. Okay, so let's go through this real quick. So we're going to write down here that natural log of m times n. Let me make this, it's like driving me nuts. It's a little bit too, there we go. Let's try this. Natural log, oh, that looks better. M times n, that's multiplication, right? It equals natural log of m plus natural log of n. Really, really. So the log of a product is equal to the sum of each part. It's a log of it. And if I have division, the only difference is it's subtraction. So if you have natural log of m divided by n, it is equal to the natural log of m minus the natural log of n. And this comes in really handy because, believe it or not, you already know one. We did it when we did parent functions, but remember, e to the x and natural log are inverses, right?
Say that again?
E and natural log are inverses. The exponential function and natural log functions are inverses, right? We graphed e to the x. Remember that? Okay, I'm going to add a page here, and I'm going to show you something. Okay, remember the e to the x graph? What was e to the x at 1? I mean, at 0 it was 1, right? And then at 1, it was a little bit more than a third. And then at 1, it was a little bit more, less than a third, right? It did something like this. Yes? That's e to the x. It's something like that. Well, guess what? For inverses, we go across the line y equals x, right?
Yes, what is natural log look like?
Huh?
What is natural log look like?
I'm about to do that right now. Funny that you should ask. Here we go. Here's natural log. So if this point right here is 0, 1, what is its inverse? Shh. What's its inverse's point?
1, 0.
Yeah. So I go down here. That's the corresponding point. So it goes down like this and goes up like this. And are those, see how their mirror image is across the line y equal x. This is natural log of x. Really, really. Isn't that cool?
So log is inverse of e.
And this is what, yes it is.
Whoa.
That was what I've been, I'm so glad you could listen to me and say it again.
Yeah.
Woo! Okay, so what's this point mean? This point means e to the 0 equals 1. This point means natural log of 1 equals what? 0.
Where can I write that down?
Push up.
I'm gonna just write it.
Yeah, right on the top. But I mean, we're going to go over this again tomorrow.
Okay.
We will. You might want to take out a piece of paper, but I'm going to give you tidbits to try to help a little bit. I want this to sink in. I don't want it to just be voodoo.
Never had to.
Okay, this is a really important point, because if you ever end up with natural log of 1, it's just 0. Does it make something simpler if you just get rid of it? Right? You can get rid of part of it. I'm still trying to convince my calculus kids. Put it away.
Cats and raccoons.
Oh, God. Okay. All right, for the next one. This is a really, 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 really important property. Can't tell you how many times I trip up my calculus kids. And why am I making a big deal of this? Because these are properties that I trip my calculus kids up with every time on a test. And on the AP test, they get tripped up on basic stuff that they don't know, they don't know the algebra, so they can't do the calculus. So for this one, notice this is to a power r. All they're going to do is they're going to take that power, because it's a log, and they make it a coefficient. So if you have natural log of m raised to the power r, it's equal to r natural log of m. And that makes life so much easier. Then the calculus is a lot easier, because you just have
Miss,
to a coefficient. What?
what's the difference between the natural log and m?
The m is just a number. M and n are just numbers.
Yeah, so it's just like,
Yeah, it's just a number.
this is just like the basic standard.
Just basic.
Okay.
Okay, so suppose you have something that it's not to the base you want.
Are you saying natural log because there's no base?
No, the base for natural log is e.
Okay.
We wrote that on earlier, right over here. See that?
Okay, yeah.
But they got tired of writing that, and it's so prevalent and so special that they have shorthand for it, and it became natural log. All right, for this, the other thing, the one I really like, because in engineering and science, we use e in natural log all the time. That's our favorite base. Not real, I mean, base 10's okay. You know, that's our number system. Our number system is base 10. Do any of y'all do programming? That's base 2. Binary is base 2. Right? That's base 2. Well, the other thing is we like to switch, and we do natural log. We can switch bases with natural log too. And this property is something I use to teach. It's key in the first semester of calculus. They need it for derivatives and integrals.
Oh, I didn't see you right there.
Can you only do that if the base is the same?
No, that's just the whole point is we're changing base. We're changing from base A to something else. We're changing from base A to base natural log.
So that M and A are numbers?
Huh?
How would you get the base exactly? It just gives it to you?
Okay, they would give you log base 2 of something, and to change it to natural log, you have to use that ratio. And
So
it's crucial when you get to calculus.
you're just gonna input it and solve it?
No, actually, we're gonna do manipulation of it in calculus. But if you don't understand the properties behind it, you won't be able to do the calculus. This is just something you have to accept and practice. It's kind of like adding, subtracting, multiplying, and dividing. Y'all need to practice that too.
You don't know how to do it, how you do it.
Okay, so changing bases like changing from 10 to E or 2. All right, we're gonna do some of these. I'm gonna do some, you're gonna do some. I'm gonna do some, you're gonna do some. Okay? We're going to start with this one. Notice it's a quotient. So I just want you to look up there. Would you use property 1, 2, 3, or 4 if it's natural log of a ratio?
Natural log.
What's it look like?
4.
No. 1, 2, 3, or 4. Not 4. Huh? Say it again? 2. It's this one, right? So you're going to do it like 2. So if it's natural log of m over n is natural log of m minus natural log of n, if I have natural log of e over 3, will that be natural log of e minus natural log of 3? Now here's where comes the fun part. See how that e is written there? Is there a power missing? Is it really to 1 power?
Yeah.
And then do e and natural log undo each other? And what are you left with?
Natural log?
1. 1. Huh? I'm just doing the first part.
Oh.
So this equals 1 minus natural log of 3.
Because they're inverses? They cancel.
Because they're inverses and they undo each other.
Okay, cool.
And you just have to remember that e is e to the 1. You have to remember that there's this 1 power right there.
What about the 1 power?
That's the answer. Because I undid these, what's left over is the 1.
Okay, so 1. Oh, okay.
Okay? This one is multiple problems. Let's see, I may want to do a different one first. Let's do this one down here first. Let's do C. Is that a product? Yeah? So how would you expand this? You would expand it by going, if it's a product, what do I do? It's the log of the first one, so it's log
Natural log.
base, that's not natural log, it's log base A of 36 plus log base A of x. And depending on what the base is, if the base was 6, we could do more. But right now we're just practicing expanding it. So this is expanding it.
Is that number 3?
That's C. And it's, no, it's number 1. That's number 1. See, it's number 1. For real. This is property 1. Let's go back and do B now. For B, can you rewrite 0.5 as 1/2? Make this 1/2.
I'm always skipping.
So is that a quotient? Right? Everybody see that it's a quotient? And I'm going to be even weirder to you. I'm going to make you change this to logs. If I want to change this to a log, a natural log. I want to do a quotient and I want to make you do a natural log. I just want to show you that you can do it all at once, right? So watch, this is what's going to happen. Because I like natural logs because we use them a lot. When you're doing the natural log trick, remember it's the m over the a, right? So it's going to be natural log of 1/2 over natural log of 3. Really, really?
That makes sense.
Okay, you take this thing, you put it up top, and you take this base and you put it down on bottom. Base is the base, it's bottom, right?
So what's the difference between natural log and log base?
The same.
It's the base. Log can have, notice this is a base 3, whereas natural log is base E.
Base E.
Base E. Okay, now can we do something with this also? Watch, natural log is this so that was property, so this was property 4, but I'm about to do property 2 again. So can I change that to natural log of 1 minus natural log of 2 all over natural log of 3? And what did we say based on the graph? What's natural log of 1? Remember my graph? If you don't remember it, what is e to the 0 power? So this has to be 0.
Minus natural log of 3.
You see it? Do you understand what I'm saying now? You getting it? So what does this become? Does that simplify to negative natural log of 2 over natural log of 3? And right now, we're just playing. There's no real purpose in it. We're just trying to learn the properties. Eventually, are we going to have to solve equations?
So what you're telling me is that you can
This
three of those
isn't an
steps, two of those
equation.
steps in one equation.
Uh-huh.
Is that gonna be hard?
If y'all will work with me, it's not, because I'm really good at this. I can show you how easy this can be. Now, I'm not going to make you memorize these properties. I'm going to give them to you. If I give you these 4 every freaking time, can you use them?
Yeah.
Because I'm going to give it to you. I just need you, it's going to be there. But after you've done it enough times, will you know it? If you do it enough times.
Yeah.
But will this be there like a security blanket? Their properties will always be there if you will just look and use the right one. There's no excuse for not getting it right.
Mm-hmm.
What's the hard part? Know which property to use. You gotta take practice. Okay. So we did all those, right? Oh wait, we got one more. Okay, so
Is that number 2?
this is that same line all the way over to D. So notice it's that same thing.
Is that the,
Oh wait, we got 2 things here. It is 2, but it's also 3. Are they both to a power? What power, how do we rewrite the square root of x to write as a power? From our last test. Yeah. So this becomes,
wait, why is it number 2? When it wasn't number 3?
I'm about to show you. This is going to be log of x to the 1/2 over b cubed. Now first we're going to do the quotient part, which is property 2. First we're going to do 2. So we'll call this 2. We're going to do 2 first. So is this going to become log of, and it's base 10, because is that missing right here? Is it base 10? You don't have to write it, but do you need to know it? It's base 10, right? If it's not there, it's base 10. This is going to become x to the 1/2 minus log base 10 of b cubed, but we're not done yet. What can we do with those powers? It's property 3. Look at property 3. Can I do property 3 now?
I thought that
Bless
was
you.
property 3 up there.
No,
In the
this is
red.
property 2. 2 is the division.
So what's that in the red?
The red, that's what I'm about to do, property 3. Can I take that power and become a coefficient? And they're both base 10. Kevin, focus. You're going to need to be able to do this in order to solve. What are you looking for? Here, you see it? You're right.
So Miss White, what's that up right there on the right?
All right, moving right along. Now, simplify. This is condense. Notice what that was. This was this was expand. Now we're going to simplify. So look at A. First off, if there's a coefficient, do you need to make it a power? Take this, make it go here. Take this, make it go here. Yeah? It's the power of the argument. By the way, do y'all know what I'm talking about? We might want to do that. Hang on a second.
Yeah.
Let me write this down because I don't think y'all necessarily know this. So we have log, right? This is B, that's the base. And then you have whatever this is, so this we'll call this M. That's the argument.
Nice.
It's the thing that you're operating on. So like when you have square root of something, like square root of x, x is the argument. X, this is the thing that you're operating on. M is the thing we're operating on. So when I say argument, I'm talking about this piece. When I talk about the base, I'm talking about this piece. So back up here, notice that coefficient becomes the power of the argument. It's the thing that we are operating on. What?
Which one's a coefficient?
Coefficient's the number that's multiplied all the way out in front.
I got it.
And then guess what our base is? Our base is 6 on this. See the base? That's going to become important when we start solving.
Okay.
You need to know what base you're in. Okay, when you do that, you end up with log base 6 of 5 cubed plus log base 6 of x to the 1/2 power. Now, what does the plus do? What property is it? 1, 2, it's 1. Does that mean I just get to multiply them? Does everybody see it? We're just going to multiply them. But what is 5 cubed? You learned this last unit. It's 125. So it's 125. And then what is, and then it's just the square root of x, right? Oh, look what we did. We took all that and mushed it together.
Wait, why did you do?
Why to do what?
How did you get logs to the base? Log base 6.
It gave me log base 6.
But how'd you go from the blue to the black?
What I did was, because this, look at property 1. I'm going from the right to the left. In property 1, if they're added, that means when I compress them,
Oh, when you're simplifying it?
yeah, when I'm simplifying,
Okay, so you're going from the right side,
yeah,
which is log base 6x.
yeah, and I'm mushing it together, so that means I'm multiplying them
Oh, okay.
in the argument.
So when you go from right to left, you multiply?
Well, see how it's if the logs are added, I'm going to multiply the arguments. Is that what that
Okay.
shows?
Multiply. I'm gonna write that down.
You should write that down. It's written in the, read the words right here.
Okay.
Okay, right here. What do I do with the coefficients? So we're going to make this the power, yeah? You have the power, do so. And then, Kevin, if I'm subtracting, what do I do? What property is it?
A
Uh-huh.
negative.
Yeah, nice try. Maybe you ought to start paying attention.
Nothing, I guess.
Or what?
So this is going to become, so when I do that first part, I get natural log of x squared minus natural log of 3 cubed, which is what's 3 cubed? Y'all know this. 27. So if I'm subtracting, then that becomes natural log of x squared over, and this one's actually not, it's 2, over 27.
This one.
What, dear?
How do you know if you have to simplify or expand it?
You read. I'm not joking. It says simplify, condense.
I was gonna say that.
I'm going to tell you what I want you to do. But if you just look at it, if you have 2 logs added or subtracted, you want to compress. If you have a log where you've got a product or a quotient, you're going to want to expand. You're always going to want to go the opposite
But it's
direction.
always gonna tell you like.
It's usually going to tell you unless it's a solve, and by the time we get to solve, hopefully you'll understand it.
Okay.
Okay, moving right along. What do we do with the coefficients? Uh-huh. They're all going to come powers, right? So now I have log base 3 of x to the 4th minus log base 3 of y to the 5th minus log base 3 to z to the 6th. And what happens if I have a difference? Property 1 or 2? 2. Now, I need y'all to listen. There are 2 minuses and 1 that's positive. That means this is on top, and it means that these are both in the denominator. They're both minus, they both go in the denominator. So you're going to end up with log,
So what is the second two go on the bottom?
huh?
Why is the second two on the
You're subtracting both of them.
Wait.
Anytime you subtract, it goes into the denominator. Anytime it's not subtracted, just added, it goes in the numerator. So this is going to, just hang on, let me finish this. It's going to be the x to the 4th is on top, the y to the 5th and the z to the 6th are on bottom. Does that look like what we did, only now we've taken it to the next level? Is that why I had to have y'all have to do that? And y'all can't do it yet. Do you see why we're in a world of hurt now? Because you couldn't do that, and now I'm doing logs with it. Oh no.
Wait, miss.
Lions and tigers and bears. Oh my, what?
But it's gonna get way harder.
So the arrows on the top, they're going from left to right? Is that what it's trying to say? Can you put that?
What I'm telling you is that anytime it's a coefficient, it's a number times the log, you're going to make it the power of the thing that we're operating on, the argument.
Say that again?
Anytime there's a coefficient, a number times the log, it's going to become the power of the thing that the log is operating on. The x, the y, the z.
Would it be more than one X sometimes?
We'll talk. Just let's keep this simple. Let's not get carried away, okay?
Okay,
Okay, one step at a time. I know, but one step at a time. Okay, now you're going to solve without a calculator. You're not really solving, you're just simplifying. It says solve, but you're simplifying. Here's the thing you need to know. Remember, en does natural log. Well, guess what? Log base 2 undoes 2 to the x. 2 to the x undoes log base 2. I need you to just look right here. Do you see that these are the same base?
Oh, since they're like... both
They
the same.
undo each other, and the answer is negative 13.
That makes sense.
That was easy.
So if it was log base 1 to the 2, it wouldn't...
If you have different bases, you would have to convert. There's that formula to convert.
So does E in natural log cancel out too?
Yes, dear. Look right here. All the way up here. Oh, look what I already did. Mo.
I have it written down.
Okay, then you need to process what you write down. Oh, speaking of which.
I did, I said 8.
Oh, look. Right here.
That's what I've been trying
That's
to
what
do.
he's talking about. Okay, what about over here? What do we have to do first?
Base, base.
Because yours fits.
Do you need to compress this?
Wait, what is L?
Kevin,
What is
over
L?
there. Move over a desk.
Base 6, 9 times 4.
So this is going to give me log base 6 of 9 times 4. What's 9 times 4?
36.
And what's 36 in terms of base 6? 6 to the what? Squared. What do these do? Cancel and you get 2. Too easy. Do you see that that's too easy? Yeah? It's not bad. Huh?
Finish up tomorrow.
No. Nice try.
That was a good try.
Yeah, good try. What about this one?
Oh, it's pretty good, man.
We're gonna finish through this. We're gonna do this, and we're not gonna do that. We're gonna do the rest of it tomorrow. But I want to finish this. This is easy.
I was like,
When it's subtracted, what do you do?
divide.
Divide. So you got log base 8 of 16 over 2. What's 16 over 2?
I can't even look down.
So it's
Oh
log
my
base
God.
8 of 8. What's the power of 8? 1. So what's the answer?
0.
Why did you say 0?
Because it cancels out.
No. What's left over?
0 times 1 is 0.
OMG.
Enough.
All right, next one.
0 to the 1 is what?
Okay.
Ball game.
0. Oh, don't even go there. Don't. Shh. Okay. Notice I did it the other way around. Is this base 5 raised to a log? But before we start, do we need to compress this thing?
Can we get 1?
So it's 5, and then it's log base 5,
What's 6 times
42. Okay, are these the same base? Do they undo? And the answer is 42. Has anybody seen or read A Hitchhiker's Guide to the Universe? Thanks so long, and thanks for all the fish. The answer to life is 42.
Oh, I've seen that.
Oh, well, lost on you.
They were at the base.
Okay. So, y'all's mission